In this video, I want to take a look at the law of cosines and how we can use it to calculate triangles. So here's some information about a triangle. I've got an angle of 50 degrees and the two sides that make it up are lengths 4 and 7. If that's the information you have, this is a fixed angle, that's a fixed length, that's a fixed length. There's only one length that this other side could be. Right? This is what we call side angle side situation. I have two sides and the angle in between them. This is a fixed triangle. Any other triangle with this information is congruent to this one. So I ought to be able to determine what the lengths and the angles are. Okay. Thing is, the law of sines didn't help us on this because for each angle and opposite side there's one that you don't know, something you don't know. So let's call this A and B and C here and call that A. So I need something other than the law of sines here, but here's where the law of cosines helps, because I can look at the law of cosines. I got the angle A, which is 50 degrees. Its opposite side is the thing I don't know. Here we go. A squared equals, well, B squared plus C squared minus 2BC cosine A. That's the law of cosines. So this is what I'm using. A squared equals B squared, which is 7 squared, plus C squared, that's 4 squared, minus 2 times 7 times 4 times the cosine of the angle here, 50 degrees. Okay. So here we go. A squared is equal to 49 plus 16 minus, what's that, 856 times the cosine of 50 degrees. Now, one of the most common mistakes is right here. People will say 49 plus 16, that's 65, and then they subtract the 56, which would be 9, and then they say, okay, I need 9 times the cosine of 50. It's like, no, wait. Order of operations says you got to, those two go together first. So here I have A squared equals, that's 65 minus 56 cosine 50 degrees. So that's what I'm going to type into my calculator. I'm going to see. So I pull my calculator up, and I don't know if you can see it, probably not. So I'm going to do it over here. 56 minus, no, sorry, 65 minus 56 times the cosine of 50 degrees. Right? Quickly check, make sure I'm in degree mode. I am. And I get A squared is 29.00389, whatever. Okay, so A is going to be the square root of that. And I'm not going to round. I'm just going to leave it as it is. So in my calculator, I'm saying the square root of the previous answer, and it gives me 5.3855, whatever. Okay. So I've calculated now that this is 5.3855. Okay. Depending on the application, of course, will determine how many decimal places I might need here. Now I got to find the angles. Okay. And I could use the law of cosine to find the angles here, but actually I always find it easier to use the law of sines if I can. I have an angle 50 and the opposite side now, so I can use the law of sines to find either angle B or angle C. The thing that I have to be careful of is that whenever I use the law of sines to find an angle, there's the possibility of two solutions. However, the triangle doesn't necessarily have that possibility, because I look at this triangle right here and I see the three side lengths, 4, 5.3, and 7. 7 is the biggest one, which means B is the biggest angle. The only angle that has a possibility of being bigger than 90 degrees is B. And that's the type of angle that the law of sines gets wrong. If you have an obtuse angle in your triangle, the law of sines won't find it. The law of sines always ends up with a small angle, because when you're taking the inverse sine, it always gives you a first quadrant angle. So if B happens to be a second quadrant angle, the law of sines isn't going to help you. Well, you got to be ready to adjust to what you do get out of it. However, I don't have to worry at all about angle C, because C is not the biggest angle. It's not bigger than 90 degrees. I can't have two angles in a triangle bigger than 90 degrees. I mean, that would already add up to more than 180, right? I'd have to have a negative angle for the other one. So, finding the law of sines, use the law of sines to find the smaller angle. Right? Angle C is smaller than angle B because side A is smaller. Sorry, side C is smaller than side B. So the 4 is less than the 7. So angle C is less than angle B. So I'm going to set up the law of sines here. I've got the sine of angle C divided by its opposite side, 4, equals the sine of 50 divided by the sine of 50 divided by its opposite side, and that's the thing we just calculated here, 5.3855. And I'm going to use my calculator. Again, I still have that number waiting. I haven't rounded it yet. So here we go. The sine of C is 4 times the sine of 50 degrees divided by 5.3855. So in my calculator, I type 4 times the sine of 50, and then I'm going to divide by the previous answer, so I don't have it rounded. Well, I have it rounded to 10 decimal places rather than 2 or something. So anyway, I find that the sine of C is equal to 0.568965, whatever, right? So C is the inverse sine of that. C equals sine inverse of 0.568965. And again, I'm not going to round it as much, I'm going to say, tell my calculator, please tell me the sine inverse of the previous answer. And it says, okay, it says you screwed up. I typed sine instead of sine inverse. So I need to do okay, and then I'm going to do, let's see if I get this right now. Alright, I get 34.68.7, whatever, let's just call it 0.7. Right. Now that I have angle C, I already knew angle A. Where was I, right? Angle A was 50, and this is now 34.7, so I can get angle B by subtracting from 180. So angle B is 180 minus 34.7 minus 50, and I think it is going to turn out to be bigger than 90 degrees here. So I've got 180 minus my previous answer minus 50. Yeah, and I've got 95.3 degrees. So sure enough, that actually is bigger than 90 degrees, and the law of sines would have gotten it wrong if I tried to solve angle B with the law of sines, okay? But you can always do this right. You can always be sure that use the law of cosines to get that other side. Now that I know all the sides, I know what the biggest angle is. Use the law of sines to find the other small one, right? I already know one of the small ones. I'm looking for this one. Okay. If it turned out, if it turned out that side A was already bigger than 4 and 7, then it wouldn't make any difference which one you could do B or C with the law of sines, because you know they're not going to be bigger than 90 degrees. Okay. If you're doing the law of sines on an angle, to find an angle, make sure it is smaller than 90 degrees. So anyway, there's one example. I think I'm going to stop this video and do another example in another video.